Problem number 5 tells us the calcium concentration and also the fluoride concentration in a solution. And we're asked if a precipitate will form if the KSP for the salt formed from these two ions is 3.2 times 10 to the minus 11th. So let's think a little bit about how we're going to work this one. We're given two ion concentrations. And together, these ions make up the sparingly soluble salt calcium fluoride. Since it's a 2 to 1 ion charge ratio, we need to balance that off by having 2 copies of fluoride for every 1 of calcium. Now when that material dissolves, it will of course make calcium 2 plus aqueous ion and also some fluoride. But specifically, we're going to make 2 copies of fluoride for every 1 of our calcium by virtue of that 2. So this is the reaction that occurs. Now we're actually going to try to run this reaction in reverse, aren't we? Reason being, we're mixing the calcium ion and the fluoride ion of specified concentration. So this isn't necessarily an equilibrium system. We're just mixing these ions together. So as a consequence of that realization, I hope that you realize that what we're actually doing here is we're going to compute our QSP, and then we're going to compare it with the KSP value. And in doing so, we're going to figure out which direction this equilibrium is going to shift, if any. So to help us do that, we need to remember how to compute our Q term, our reaction quotient. And you may remember from chapter 17 that all the QSP is, it's like the equilibrium constant, except that initial concentrations are non-equilibrium concentrations. So our calcium concentration was specified as being set as 0.01 mole per liter, and our fluoride concentration was specified as being 0.002 mole per liter. Now again, we got to square that by virtue of that 2, but we can handle that, right? No big deal. So if I take 0.002 and I multiply it by itself, I get 0.000004. I believe that's correct, right? 5 zeros, yep. That's 0.002 squared. Now I still need to multiply that by 0.01. But if I do that, I get what? 0.0000004. Just make sure I count my zeros. 3, 6, 7. Yeah, that looks like it's right. That is my value for the QSP for this particular situation, which is governed by the concentration stated of these ions. Now, what do I do with this? I want to ultimately figure out whether a precipitate will form. To help me do that, I have to compare QSP with the value of KSP. Now in the problem, I read that the KSP is 3.2 times 10 to the minus 11th. It's a very small KSP. So in this case, my QSP is quite a bit greater than my KSP, isn't it? And what did that mean in terms of equilibrium shifts? We studied that leading up to the last exam, didn't we? If Q is greater than K, we're product heavy. In this case, that means we have too much of our ions. We've got too much calcium and fluoride ion. And the system, to reestablish an equilibrium, will shift back to the left. So guess what? We could fully accept or expect that a precipitate will indeed form based on our mathematical prediction. And that's all because Q is greater than KSP. Our ion concentrations are too large, and a precipitate will certainly form.